Hi everyone, welcome back to Chem Health ASAP. We are continuing our march through history and the discoveries that have shaped our current understanding of the atom. Today we are mostly going to be focusing on J.J. Thomson and Ernest Rutherford, although we will mention a couple of other scientists in there. So let's start in the early 1900s with J.J. Thomson. Now he was working with cathode ray tubes, and he demonstrated that these rays consisted of negatively charged particles, and he actually calculated the charge to mass ratio of these particles. Now today we know these particles as electrons, and they are subatomic particles of the atom. So J.J. Thomson decided to propose a new model of the atom in 1904. And what he did was he took a sphere of diffuse positive charge and interspersed electrons in there. He called it his Plum pudding model. Now, the reason why he had a sphere of diffuse positive charge is because he knew that atoms were usually neutral. So if you've got a negatively charged electron, you must have a positive charge somewhere in the atom to balance that out. Now, I think the plum pudding model looks a little bit more like a chocolate chip cookie, but this was early 1900s England, so we'll let it slide. Now, to expand on Thomson's electron just a little bit, I do want to mention Robert Millikan, who in 1909 devised his oil droplet experiments, and he actually calculated the magnitude of the charge on the electron. But I'm not so much focused with charges in this video. I really want to talk about subatomic particles. So we have Thomson, he's discovered the electron, he's got his plum pudding model. One of his students, Ernest Rutherford, wanted to prove the plum pudding model of the atom. So in 1911, he devised his famous gold foil experiment. And what he did was he took a very thin sheet of gold foil and he just bombarded it with alpha particles, which are helium atoms. And what he expected to see was as the alpha particles passed through the gold foil, they would be deflected a little bit by the atoms of the gold, so that the electrons and the positively charged sphere would attract some alpha particles and deflect others. But what he found was completely different. Most of the alpha particles just passed straight through the gold foil as if nothing was there. However, a small percentage was deflected back at very large angles. Rutherford later said that this was like shooting a cannon at a piece of paper and having the cannonball come back at you. So it was completely unexpected. Now, obviously, we need to revise our view of the atom. The plum pudding model was out. Rutherford put in a new model in its place. Rutherford changed Thomson's model of the atom, and he also proposed a new subatomic particle called the proton. The proton has a positive charge, and it resides in the center of the atom in a very small, dense nucleus. Now, the electrons, the negatively charged electrons, were then on the outside of the nucleus, and effectively, this made the atom mostly empty space, because Rutherford saw that most of the alpha particles just passed right through and were not deflected at all. However, any alpha particle that would hit that small, dense nucleus would be deflected back at very large angles. Now, of course, Rutherford understood, just as Thomson did, that atoms tended to be neutral, and so the number of protons in the center in the nucleus equaled the number of electrons outside the nucleus. So our atom now has positively charged protons in a small dense nucleus, negatively charged electrons that reside outside of the nucleus. We have one more basic subatomic particle that I want to talk about, and that is the neutron, which has no charge. Now, the neutron was discovered by one of Rutherford's students, James Chadwick, and he discovered the neutron in 1932. So what I think is really cool is you have Thomson, who mentored Rutherford, who mentored Chadwick, and between these three scientists, we have our three basic elementary subatomic particles. That's as far as we are going to go today. In our next video, I do want to talk a little bit more about the electron and specifically trying to figure out where the electron is. It ended up being more difficult than anybody thought it would be, but we will cover that in our next video. I hope this was helpful, and thanks so much for watching.